My name is Justin Cormack. I work at Docker, and I'm here to talk about Containerd, the newest CNCF project. Well, one of the two newest CNCF projects. We're incredibly excited about joining the CNCF. When I submitted this talk, it was still a hope and possibility rather than the reality it is today, which is really great. And we're really excited to be working in this community. And this is this conference has been really exciting. I've spent so long talking to everyone about Containerd and how we can work together, and we'll see how it relates also to other CNCF projects. I mean, Containerd really is a cloud-native project. It's really heavily built on gRPC, which we'll talk about later. Prometheus is a really important part of it, and it's going to be a really key component in Kubernetes, which we're really excited about. So it really kind of fits into this ecosystem, and hopefully it will also affect many of the other projects in the area as well. Containerd is not quite a new project. We actually started it in 2015, but it was relaunched in 2016 with the aim of becoming what it is now, an open, not Docker-controlled project with a new scope and a new master branch where the real new development's happening, and the old work we were doing before, which Docker uses, has been kind of moved into the 0.2 branch and is just in maintenance mode now. So it was announced as a new project, which was slightly confusing to people who said, but there was already a Containerd, we were already running it, so it's already part of Docker. This is confusing. So it's new in scope and project governance and things like that, but there's some existing code. It's a core container runtime. What does that really mean? It's the infrastructure that does the kind of low-level bits of managing container execution, making sure your containers continue running, connecting to them, letting you pull images that you want to run, and giving you plumbing. And so it's kind of that group of things that just locally runs containers. It's not a distributed component, it's a single host component. You could say, well, isn't that what Docker is too? But Docker is, in fact, a whole platform on top of a container runtime, and it's opinionated. It does clustering. It's a commercial product. So it's not. Containerd is really just the component that you need to do the low-level bits without a user interface. Really, we'll talk about gRPC a bit more. Without clustering, without any of those things. So it's a tool for building bigger systems like Docker, like Kubernetes. In terms of the ecosystem, the aim is that Containerd should be used by everyone on every system, on Windows, on Linux, and it should support every high-level container platform that sits above that: Cloud Foundry, Kubernetes, Docker Swarm, and AWS, and container services and so on. So, and the Microsoft container services and so on. So it's a component for people who are building platforms like Kubernetes and people who are building platforms like AWS, and people who are building platforms like IBM's Bluemix. It's all these. It's aimed to support all these equally and not have any kind of preference to any particular one. Obviously, as we're here at KubeCon, and it's important to talk about Kubernetes in particular, Docker's always been the default runtime for Kubernetes, and our plan is that Containerd can replace that use of Docker, basically by being another runtime that fits with the CRI, but being one that, as we build it, we make sure it's going to work with the CRI, that it's which is the plugin layer for Kubernetes for runtimes. There's already integration work going on, and in fact, a couple of days ago, a pull request was open, saying do not merge, but it's a starting point, which is really cool. Bits of it are kind of hacky, but the aim is, as we build Containerd, to work alongside with both people in Docker and people in Kubernetes and people in other runtimes to make sure that as we build it, it's meeting the needs they have for integration. The requirement for 1.0 is that it supports at least one runtime. In practice, that means it supports at least Docker and Kubernetes, and it's basically working ideally shipped. And so that integration work is incredibly important, and the people working on it, I've met some of them yesterday, and it's really, really cool work, and it's really important work, and it's really valuable work for us. It's really important that we integrate into the Kubernetes community and provide what Kubernetes needs. Tim Hockin was at the Containerd Summit that was about a month ago, and this was one of his slides where he explained why it matters and why Containerd is important for Kubernetes. It provides just what Kubernetes needs without all the other bits of the Docker platform that are basically useless for Kubernetes, because Kubernetes has its own view on that. It's designed to be embedded. It's not designed to be a standalone system. It doesn't have tight dependencies. It basically lets you control workflows and things how you want. And it basically just gets out of the way and provides just the necessary parts that Kubernetes needs to do exactly what it wants to do. And this has always been the aim, and it's really important for the project that it is useful in this way, and it is exactly what people want, because we want it to be successful by providing what people have been asking for a long time. So this 1.0, we've got a super aggressive, super ridiculous timetable that we are planning to ship 1.0 in the second quarter of this year, the second quarter starts in a couple of days. So it really helps that there was a previous 0.2 branch, so we could take bits of it were working. In particular, the runtime code was already working because that was the bit that was already being used by Docker. So we have something, it wasn't from nothing. The image handling code is pretty much all new. So there's been a lot of work on that, and it's coming along really well. So that evolution is definitely helping us, but it's a super aggressive deadline, and we need the community to help ship that. But it's, and we need people to, start integrating it into Kubernetes now, which is happening, which is great. So it'll be streamlined and small and focused to get to 1.0 that quickly, with extensions via plugins rather than jamming loads of code into the repo. We're hoping to use the new Go plugin infrastructure. Maybe that won't work, but it'll still be pluggable and buildable, and extensible. Once we ship 1.0, it'll be supported for a year as a stable product that people can use in their platform without worrying about API breakage or anything. And then it can move on to 2.0, which can do very different things. It doesn't have to be we don't have to have such an aggressive timetable for shipping it. It'll be there and running. We'll have learnings from experience, and we can say where we want to change APIs or change architecture. And so there'll be whole opportunities for exciting new directions for the project to take and evolve in new ways, and the community can lead that wherever people want for their runtimes, and based on the experience of using it in production. So limiting scope is important in order to get this thing out, and to make it not a giant project that's unapproachable. So we left a load of stuff out. I'll talk about these things in a minute, but there's no networking, no volumes, no logging, and no build at the moment, which is all kind of a lot of the stuff that people kind of expect. So I'll talk about a bit about why this isn't there. Networking, we had a lot of, some time back, there was kind of long discussions about trying to standardize networking, and Docker and Kubernetes didn't agree about networking and went different ways. And have very different interfaces. So one of the first issues that was opened as soon as we announced the new Containerd was issue 362. What should we do about networking? And there was a good discussion, and the answer was, let's not do anything about networking in Containerd. Let's not be opinionated. Let's basically provide some methods so you can join an existing network namespace. You can use OCI hooks, which is how Runcs worked. Or probably the cleanest model is Containerd has this nice separation between creating a container and running a container. They're not one operation, so between those two things, you can set up networking into the network namespace of the process and do what you want. So there's kind of, but any of these methods work, and they've been used by other projects. Everyone seems really happy that they don't have to. They can just do what they want with networking, keep networking how it works now in their platform, and Containerd is not going to get in the way. Volume management. Pretty much the same thing, only there's even less standardization. I just wanted to point out that there is now a new storage interface standardization proposal that's in kind of early days, and if you want to get involved, because you care about storage, do look it up. But again, Containerd doesn't really care. It's mounts as far as it's concerned at that point, and it's file systems, and that's it. There's no log management really at the moment either. You get the streams that come out of containers, but there's an issue about this, issue 603, which is, we had a discussion about in the salon yesterday. This could change. There's some sensible things that people want to do about maybe adding timestamps and a little bit of log formatting for some applications. There are different use cases that have to be allowed for, so it has to not get in the way of people who are using container outputs as binary streams, which Docker does sometimes if you're using Docker in a Unix pipeline or something like that. So not everything is log structured. It's kind of, so there's nothing, it doesn't do much yet with logging, but there's still an open issue, and if you're interested in that, please participate and contribute code and think about it and look at the issue. There's a lot of useful points on that. There's no build. Docker build is kind of a weird Dockerish thing, which the assumption right now with Containerd is you build your images in some other system like Docker or any other set of tooling you like, and then you run them. And Containerd will run them. It has the internals to handle some sort of build tool, but it doesn't have any opinion about what a build tool should be. It's just you can snapshot containers that exist. It's not going to, build is out of scope as a thing it does. It's not, this isn't Docker we're building, it's Containerd. So that's everything that's not there. What is it? What is there? The best way to understand Containerd is to understand it's a gRPC interface, and the best way to look at the project if you're first starting is to go to the API directory, which is conveniently right at the top of the GitHub repo, and you look at GitHub and look through and look at the gRPC APIs, because they are really how Containerd works, is built. There's a few bits missing from them, but I'm going to cover the high level parts which are there. There are some bits around metadata that don't have interfaces yet, but will do soon. But pretty much you can start at the top level of the APIs and look through and really understand the project. And I'm going to kind of run through a little bit what these are. This is kind of the Docker storage architecture, which is kind of complicated and everyone hates. Containerd is really much simpler. It has a store for content. It has snapshotting. So dist is on the left is the image tool, and Kutter is the container runtime tool. So these are notionally the two halves of Containerd. They share a metadata store, which is names and tags about things, and it's a really simple structure. It makes rootfs. I'll tell you about that a bit more in a minute. So gRPC API number 1 is content, which is a content store. You take things in that are basically Docker images or other OCI images, which are basically which are content addressed stores. So basically, they're a big blob of stuff with a hash. In simple terms, they actually are often file system layers, but conceptually, from the content store point of view, it's a blob, and you want to address it by content. That means you know what you're getting because you've got an external name store somewhere, but you know that it's reproducible and is the same thing you get every time. The interface is fairly straightforward. Read and write. There's a slightly more complicated thing with write, so you have an updating stream while you're writing the content. So you can, if you're fetching something remotely and writing takes quite some time, you can see which bits you've filled in so far of the thing, restart and anything like that you need to do if the network connection goes down and you want to finish committing your content blob. When you get it out, it's much more straightforward. You just get a stream of stuff. And you can see the status, which you can use for giving a progress bar for the user or any kind of feedback about where you've got or just working out if you finished yet. gRPC service number 2, rootfs, which is basically about taking a bunch of layers that you've got from the content store and unpacking them and taking the bits of the image and building something that you could later actually run a container from. It's very much a do-it-yourself interface. The mounts call doesn't mount everything for you. It just tells you what you need to do to mount it. So you can do useful things like privilege separation, things like that. So it's or modify the mounts before you actually do them if you want to add new flags or things like that. So it's kind of it's very unopinionated and straightforward. There are various ways of doing the layering for mounts that kind of have evolved from the Docker drivers. Overlay Btrfs and a sort of straightforward VFS thing. These are not comprehensive. They're meant to be extended by plugins, but they cover the three basic styles of doing layering, which has been successful in Docker, and we've kind of learned to laugh, but with much nicer APIs because the APIs are really clean and straightforward and understandable, whereas if you've ever looked at the graph driver code in Docker, you've probably run away screaming. But this stuff's understandable and nice. Then there's execution, gRPC service number 3. This is quite relatively straightforward. I want to create a container. As I said, create and start a split. So there's the 2 stages, delete, list, and then get events from them. Really quite straightforward, kind of obvious interface to running containers. And then finally there's a shim, which is a kind of, the shim's a small process that's attached to every container that sits there and handles its I/O. One of the purposes of the shim is to mean that you can completely restart containerd if you want to, for example, upgrade it while your containers are still running. And the shims can then be reattached and all your containers keep running. So if you want, in theory, your upgrade process for containerd may be that you actually upgrade containerd without ever stopping your containers. There's a few other use cases of the shim as well, kind of where some of the log handling happens, things like that. But that has a slightly more complicated control plane. It's also a replaceable component if you want, because it's a standalone binary. So if you want to make a custom shim that follows this interface, you can also do that. I think that the VMware people who are running containers, running virtual machines as containers are doing a custom shim part because they're using a very different backend. So there's options of customization around that too. So gRPC is really, really important, and totally everything's built around the gRPC interfaces. there's a command line, but it's not the API. It's just there for running tests, playing with. And particularly while it's been developed, it's been quite changeable, to say the least. The options in the command line have often changed completely every week, and it's been kind of confusing for people. It'll probably stabilize a bit more soon, but it's useful just for playing with, because you can do quite low-level things with the command line. I'll show you some of the examples, but it's not the way that we expect anyone to interact with this project in the long term. We expect the gRPC interfaces are the API. gRPC is how it's built and how it works. So as I said, there are two commands, dist and cutter. So dist lets you do everything with images and root FSs. It's pretty low level, which is quite cool. You can do things like apply, which you can build up a layered file system piece by piece, which is quite fun and teaches you how it works, and you can see what's happening, but it's really low level, and obviously only for developers. As I said, it's not an end user API, but it does correspond to the gRPC APIs that there are to a large extent, which is quite cool. And then cutter is everything about containers and shims. Slightly simpler and more straightforward. You can do run, delete, list, and get Golang profiling for information out and stuff like that, which is kind of cool as well. As of last week, these commands actually work. Before that, there was no end-to-end thing, but you can now do dist pull something from, for example, Docker Hub. In this case, as you see, you have to spell it out in full because there are no defaults. And then you can run it, and it will actually work, which is pretty cool. I can show you that at the end. As well as the gRPC APIs, which are really important, there's also the Prometheus API arrived last week in its first form, which is really nice. The gRPC API, so the Prometheus endpoint is actually really, really cool because it gives you every piece of information there is about the container, every container that Containerd is running. And I've given you a little teeny-weeny subset of it here with bits of things like the cgroups metrics for a container. So you can see how many CPU nanoseconds that container has used on each different CPU core. I mean, we're talking absolutely all the detail about what's running. And this is really, really nice, and it's really detailed. There's all the information is there, and so you can really, really understand what's going on in your system, aggregate this over your cluster, and you've got a whole Prometheus set of metrics where you can understand load and scale, and whether you've got help you understand performance issues and everything like that. And it's I think that's going to be really cool. It's much cooler than the Prometheus endpoint in Docker at the moment, because it's got so much more detail in it, and it's I'm really looking forward to using this myself. So that's the second interface that's not gRPC is Prometheus. And so those two APIs are really, really complementary and important. Windows. At the moment, the code's not in there for Windows, but it's being worked on. We will have full parity with Windows containers in Containerd, and they will just work just like Linux containers do, which will be really good. Because when the support for Docker was done, it was kind of as we were migrating to the OCI process, and Windows Windows and Linux are handled completely differently in Docker, and it's a bit messy. This is going to be really nice and clean. Containerd will just be compiled on Windows and run Windows containers through a Windows OCI standard compliant runtime, and that's going to be great. Other platforms as well. Particularly, there's loads of people finally getting their code for running containers as VMs going. The Intel Clear containers, the people doing RunV, the Hyper-V people, VMware, and I think that's really cool. If you need virtual machine isolation for your containers, that will be supported out of the box as well, just by plugging in a new OCI layer. And there are loads and loads of people working on that within Containerd and using Containerd for that, which I think is really cool, because it's been promised for so long and been really hacky and difficult, and it's going to just become another runtime you can just use, which I think's great. So overall, the aim is it's easy to use and simple. Particularly if you love gRPC interfaces, which I hope all of you do here. It's a nice, clean design, fixes a lot of the complexities from Docker. I think everyone's really enjoyed working on it as a kind of new platform where we can get away from a kind of legacy code that we had for ages that everyone's always wanted to fix, but it's difficult to do. So the narrow focus means that the people working on it are really just working on these areas, which is really nice, so that you have the people who spend their whole life thinking about images and layering, such as Derek, who's here somewhere, and they really want to make it the best system based on all the stuff they've learned in the past and all the. So I think that's really great. There's long-term interface stability with the gRPC interfaces. We know the one-year releases, so people don't have to complain about breakage every few months or anything like that. Portability. The code base is much easier to understand than Docker. It's really because of the focus. So I think that that it'll help contributors. I do think that starting by looking in the API folder and reading through the gRPC APIs. I've given you the top level summary of each, but there's more detail of them in each of those files. That just gives you that understanding in a really straightforward way, and I think gRPC is really great from that point of view. You can obviously then there's a bunch of libraries that you can use as well and things like that. But it's a really nice, straightforward structure, and I think easy to get involved with. Please do get involved. It's a community project. We want more people involved. It's currently at Docker Containerd, but it's going to be moving soon, I think, since the donation. There's a new Twitter account if you want all the Containerd news. We set up a little Docker container with a little that you can try. If you run it and then exec into it, you can run dist and ktter and see what's going on. Derek just got that set up. Now it's running end to end. It's quite cool. I can show you in a minute. But so you can try it out. Obviously, when you're doing real development at the moment, it's easiest to do it on a Linux box probably. But soon there'll be Windows and support as well and things like that. And but yeah, try it out. Take a look at the repo, read the APIs, and participate and join in. Every week there's a development report saying what's happened. This has been incredibly useful, I've found, to find out what's changed every week, because there have been a lot of changes. Hopefully this quarter will be more stabilization and a few little bits being pushed in that are missing, like the metadata gRPC APIs. But the weekly reports are checked into the repo on Friday afternoons usually, so it's good to read them over the weekend, see what's happened, where we're going, get a feel for what's happening. There's a Containerd Summit after DockerCon in Austin on the 20th of April. It's not part of DockerCon. It's after DockerCon. You don't have to be attending DockerCon if you want to come. If you want an invite, it's just get in touch with me or anyone else at Docker who's here, or Phil, who's at IBM, who's a maintainer, who can point you at the right people. We've got a whole morning on Containerd. All the maintainers will be there, or lots of them. We're covering other Docker projects in the afternoon, but there'll be time to just, if you're just interested in Containerd, just spend the afternoon with the Containerd maintainers and hack code and work on stuff and understand it and come along if Austin's not too inconvenient. So let me know. And as I said, so Derek's here, wave at the back, and Phil from IBM is here, who's a maintainer. So, Daniel as well. Okay, so yeah, we'll all be around. So please ask questions and talk to people and ask all the questions. You can ask questions now. There's a little bit of time left. I'm around all day though. But yeah, so happy to take questions now for the bit of time we've got left as well. Hello.
What's the issue about Golang plugins?
Well, there's a few issues. One is they're very new, and so no one's quite sure how it is. One is they're only supported on Linux, so that we can't use them for Windows. And there's some non-clarity about the ABI, because Golang doesn't define an ABI, so it's not clear if you can actually usefully separately compile your code and it's still expected to work. It's not clear which versions, if you have to use exactly the same version of Golang to compile it, in which case you might as well just compile it with the repo in the first place. So we're not sure. I think everyone would like to use them, but it's maybe we need to wait another release of Golang to see. More questions? Cool. Well, thanks everyone for coming, and